So now let's take a look at another operator called sizeof, which we have looked at a little earlier, but we're going to be looking at it in more detail now. So the sizeof operator is a unary operator. Unary meaning that it operates on a single operand, not like addition or subtraction, multiplication, division that require two operands. And we use the sizeof operator to obtain the size of an array or any other data type in bytes. Now, when we apply the sizeof operator to an array, and we'll demonstrate that in a second, it returns the number of bytes that array takes up, and the return type is size_t. Now, in a system that in which a floating point number takes up 4 bytes of memory, and say we have 20 elements of an array, the size of that array that will be returned by this operator should be 80 bytes. And here's a very simple demo. So, and we'll also demonstrate something else over here. So the sizeof operator, when you want to use it for an array, will only work when you use it in the same in the function where you define the array. When you use the sizeof operator on a pointer that points to the array, you get something else, and we'll demonstrate that difference over here. Remember, arrays get passed by reference, so what actually passes to a called function is just a pointer to that array. So in here we have a function prototype given up here. The name of that function is getSize, and it takes as an argument a pointer, a pointer to an array of type floating point. We also define a symbolic constant size and set it to 20. And inside the main function, we define this array of floating point numbers of size, in this case 20. And then here in the printf statement, we print out first the number of bytes in the array, and we're going to print that out as that's going to be the return value of the sizeof operator applied to array. And then we'll also do something else. And that something else is we're going to print out the return value from the function getSize, whose prototype we gave up here. Now, getSize, like I said, takes a pointer to the array as argument. And inside the function, what happens is we apply the sizeof operator to that pointer. Now remember, one of the things about passing arrays by reference was that the called function does not have any way of figuring out by itself what the size of the array is. To do that, to pass that information, we have to pass a second argument, specifically meaning that will contain the size, the length of the array. That's not happening here. So what will sizeof operator on line 21, what will that return? Well, sizeof operator is, if you think about it, over here not being applied to the array, it's being applied to a pointer. And a pointer is really just an address location. It stores an address, 0x00A356, something like that. So what this will do over here is this will just return the size of a pointer. And again, that can be different based on what system you're running your code on. But this is something you can typically expect on a modern PC. So on a system that uses 4 bytes to store a floating point number, the size of the array, when sizeof is applied to the array in the main function over here, this will return the value 80 because 4 times 20, size of the array, is 80. The second return value we'll get from our function getSize is the size that the amount of memory, the number of bytes that a pointer takes up in memory, and that on my system happens to be 4 bytes. And that's what we see on the second line. Now you can just as easily use the sizeof operator to determine the number of elements, the length of an array, the number of elements in that array. And you can use that by applying sizeof first to some array. Let's assume it's called real, and you can divide, and this will give you the number of bytes. So over here, let's say real is defined as an array of double precision floating point numbers, so 8 bytes each, and it's 22 elements in size, which means that size of real over here will return the value 176 bytes. If I'm interested in finding out the number of elements, the length of the array, I can divide that by the size of a single element, which happens to be, for double precision floating point numbers, 8. So what this basically gives you is 176 by 8, which will give you back 22, this 22. Okay, so this is just explanation of the example code that we saw. So sizeof for applied to the pointer in the getSize function returned the value 4, the number of bytes that a pointer takes up in memory. Applied to array in main, it returned 80, which is 20 times 4. Now, we can also use the sizeof operator, and this is the part that I already showed you in one of the hands-on sections earlier. We can use the sizeof operator to explore, to check the sizes of different data types, or even different variables of different data types, not just arrays. And I'll show you an example for that too. The thing to remember though is that when you apply the sizeof operator to a variable name, you have 2 options. So let's say define an integer, call it a, and you want to check its size. You have 2 options. You can either use the sizeof operator like this, or you can use it like this, function style. But if you want to check the size of a specific data type, not a variable, just a general data type, then you have to stick with the use of parentheses. So this will give you the size of that an integer takes in number of bytes on your system, on the system that you're running your code on. So for variables, one or the other. When you're checking the size of a data type, you have to use this parenthesis notation. And here's an example very similar to the one we already did, We have a main function. We define character C, short S, integer I, long L, long LL, float F, double D, a long double LD, and an integer array of size 20, and an integer pointer called that is initialized to it's to array. And then we print out the sizes of the variables that we created, array, pointer, all the other native data types. And after that, we also demonstrate use of the sizeof operator when we want to check for the generic data types and their sizes. So integer, character short, int, long, float, double, long, double. And we do that in a single printf statement. So we're printing the size of variable C, then the size of the generic, the data type character on our system, the size of variable S, and the size of the data type short on our system, the size of variable I, and the size of the integer data type on our system, and so on. And at the end, we do size of array and size of pointer, PTR. We execute this and we get as output something along these lines. Actually, in this case, this example, we'll see the exact same values when I run this on my system. Now, like I said, I keep emphasizing that this is what we'll see on my system, and that is because the size of different data types may vary on different systems. It can be different on a Raspberry Pi, can be different on an Arduino, can be different on a PC, can be different on a 32-bit PC, on a 64-bit PC, etc. So the exact numbers that you see for this code, if you run it on a different machine, can be different.